So the sequential will run each task one by one. I will suspend one processing one task, doing one task, and go to next, go to next, go next. And to run tasks parallel, you can use task group to run multiple async tasks concurrently. So you see, it's on the same time, and they can concurrently run async tasks in parallel thread. And the concepts which include async await. So the async await is a modern syntax for writing asynchronous code that reads like synchronous code. Async marks a function that can suspend, await, pause execution until the async operation complete. So let's create a sync function. So we can say we create a function that we say, for example, we fetch data from API. So the test API, we are going to use JSON placeholder, and if you go to to-dos, you can see it has user ID, the tool. So the struct of to-do will be user ID, title, and complete. And for our function, async function, we say the fetch to-dos. This function has no parameter, and it's async. So this function is a synchronous function, and throws because it's internet and go access internet. It can be exceptions, and it returns to-dos. Our to-dos, array of to-do. And this function, let's say first we need a URL. We got capital letter URL, and this is from a string, the parameter string of, let's say, this URL string. We got the URL, and then we can get the data from the data second parameter, and which equals to from URL session dot shared dot data from our URL. So we got the data. We wrap it, and this can be comes through exception, so we need to use try, and await pause execution until the async operation complete. So this we can say await. It will pause the execution until this URL session finish. And next we're going to return JSON decoder, and we create an object from JSON decoder dot decode, and from the type will be array of to-do dot self. That is the type from data, and this will cancel exception, so we can say try. And in our main function, we can say let to-dos equal to try await fetch to-dos, and we can say print fetching of to-dos from API is completed, and error, if you can hit catch, and if there's an error, just print the error catched, and we just simply say the error. And we can run fetching of to-dos from API is completed, and you can see if you use this Swift playground, it can even show you the fetched result from the API, and you can observe each other the data from the JSON decoder. And the task is a unit of synchronous work. Task group lets you run multiple tasks concurrently and collect their results. Tasks can be cancelled and automatically propagate cancellation. So for concurrent, you can see run parallel in tasks. So you can see this is the sequential, and let's do parallel. You can say function of process. So if you process the data to-dos, it's got a parameter of to-dos of type of array of to-do, and this is a sync function, and so we are going to create a unit of tasks. So we can say await, we say with task group, and the group in the code, and this for the to-do in to-dos, we got a loop, and the group of the tasks, we add the task and the operation. The operation is, we just say, over here, if you have long await task, you can do it here, but here we just say processing to-dos, processing long running tasks, and to-do ID, and which is, let's say, backslash. So interpolate of the to-do dot ID, and we got ID over here, and over here after the sequential task of the fetch to dos, we can say await process to dos of to dos, and after that we say print. So this will suspend until it's finished, and we say processing finished. Let's run, and you can see what's the size is. First, it fetch to dos from the API is sequential, and next is the running the parallel task in a group to process the to-dos, and you can see even the number. You can see the number it's running in parallel, so the number can be the same as the sequential or not. So this is first running 26 and this is 30. So what you can see is if you run parallel, each is same time running in a parallel, you're running on different threads, and after it says processing finished. Okay, so the actors, which is reference types that protect their mutable state from data releases. Only one task can access an actor's mutable state at one time, prevent concurrent access issues. So generally, it's if you mark a actor, you can say this is main actor, and so this is the actor of the main actor is the main thread which the UIs display the UIs, and you can use the actor for others. Okay, that's the basic concept of Swift concurrency. There you can see each task will be suspended until moves to next task. It is sequential, so awaits each task one by one. And the parallel is use the task group to run multiple async tasks concurrently. Perfect.